In a town of 5,000 people, 10 people have a new strain of cold. The spread of the cold through the town is given by the differential equation dn dt is 0.00024 n, 5,000 minus n, where t is in weeks and n is the number of people infected. Find an expression for the number of people infected, and hence find the number infected after 2 and 4 weeks. So we have dn dt is 0.00024 n, 5,000 minus n. So we can separate 1 over n, 5,000 minus n, dn would be 0.00024 dt. So we're going to need to use partial fractions here. So 1 over n, 5,000 minus n, is going to be a over n plus b over 5,000 minus n. Going clear of fractions, 1 is going to be equal to a into 5,000 minus n plus bn. So if n is equal to 0, 1 is equal to 5,000a, so that means that a is 1 over 5,000. If n equals 5,000, 1 equals 5,000b, and that means that b is also 1 over 5,000. So our integral becomes 1 over 5,000 times the integral of 1 over n plus 1 over 5,000 minus n dn, and that's equal to the integral of 0.00024 dt. Now I've calculated that 5,000 times 0.00024 is 1.2. So if we bring the 5,000 up over this side, we then have the integral of 1 over n plus 1 over 5,000 minus n is equal to the integral of 1.2 dt. So this one is going to be ln n. We don't need a modulus, it can't be negative. And then we have, that's not going to be a plus, is it? Well, it is to start with. So ln 5,000 minus n, we know this can't be negative because there's only 5,000 people, so the smallest 5,000 minus n can be 0, divided by the differential of the inside function, is equal to 1.2 t. So that's ln n, take away ln 5,000 minus n, is equal to 1.2 t, of course, plus a constant. So ln n over 5,000 minus n is equal to 1.2 t plus a constant. So that's n over 5,000 minus n is e to the 1.2 t plus a constant, but we've seen how we can deal with this constant. Let's just make it an a just here. Now we're just told here that when t is 0, n is equal to 10. So 10 over 4,990 is equal to a. So just simple cancelling, a is 1 over 499. So n over 5,000 minus n is going to be 1 over 499 e to the 1.2 t. Now we want to make n the subject of this formula. I might bring the 499 up here. 499n over 5,000 minus n is equal to e to the 1.2 t. So 499n is going to be equal to e to the 1.2 t 5,000 minus n. So 499n is going to be 5,000 e to the 1.2 t. Take away n e to the 1.2 t. So 499n plus n e to the 1.2 t is equal to 5,000 e to the 1.2 t. And take out the common n here and factorize. 499 plus e to the 1.2 t is equal to 5,000 e to the 1.2 t. And then n is going to be 5,000 e to the 1.2 t over 499 plus e to the 1.2 t. Now, the normal way of expressing that, this is absolutely perfectly fine, but is to multiply top and bottom by e to the negative 1.2 t, so that we have 5,000 over 1 plus 499 e to the negative 1.2 t. So now that we have this expression, we want to find the numbers infected after 2 and 4 weeks. So what we want is n of 2 and we want n of 4. So that's just a case of calculating. So 5,000 over 1 plus 499 e to the negative 1.2 times 2 gives me 108. Remember, this is the number of people, so we can't give decimal places. And all we need to do for 4 is just go in here, and that's 979. Now, it's not necessary every time to solve this doing all of the integration and all of the algebra we did in order to get this expression. In the notes, it does tell you what the form is of the solution to this differential equation. Sometimes you might need to do integration. Sometimes you could just use that form straight off and go straight to here from your differential equation. You need to read the question, look at the number of marks, and decide how much work it is you actually need to do.